Today we're going to do our presentation on the James Webb Telescope. A little bit of history. The idea was first developed in the mid 1900s. It was first called the Generation Space Telescope. After presenting the idea formally, it was approved and they began prepping for construction. Engineers and academic partners were then selected to work on the project. They began construction in 2004 and completed the build in 2011. Towards the end of 2015, all four of the instruments were delivered to NASA. In 2018, the Webb telescope was then put together. In 2021, the telescope was shipped to French Guiana for launch. On July 11, 2022, President Joe Biden released the first full color image of the Webb to the public. Overall, this build took about 30 years to complete and it cost over $10 million. And here's a picture of the first picture that it took.
And here's a picture of the telescope. Okay, the launching date. The James Webb Telescope launched on December 25th, 2021 at 5:20 a.m. on an Ariane 5 rocket from Europe's spaceport in French Guiana on the northern coast of South America. And here's a picture of that first launch on Christmas Day.
Some of the biggest discoveries were the Pillars of Creation and the Eagle Nebula. It captured the first direct image of an exoplanet. It also captured a picture of the Wolf-Rayet star, which has unique ripples and rings, and it observed four of the most distant galaxies and provided better images of the phantom galaxies. Here's a picture of the Pillars of Creation, one of the exoplanets, the Wolf-Rayet star, and the phantom galaxies.
How it works. Webb's innovative design tackles the two main challenges for an infrared telescope. It needs a very large mirror to collect enough light, and it has to be kept cold to keep unwanted sources of infrared from interfering with the light being observed. The main component of any visible or infrared telescope is the primary mirror. Webb's primary mirror intercepts red and infrared light and reflects it onto a smaller secondary mirror, which then directs the light into the scientific instruments where it is recorded. And this is like a close-up diagram kind of how it works with the secondary mirror and the primary mirror coming from the light.
And this is by Addie Winter, Zoe Thompson, and Sophia Leach, and these are the references that we used.